Welcome to the multivariable calculus section. In this section, we'll be discussing line integrals. Now, this is an entirely new concept of integration. So, line integrals state that we have a known path, which is the integral of a function along the curve, or a path integral. So, it is important to recall how to parameterize equations. So here we have x1, y1, z1, x0, y0, z0. So essentially we're just stating that we have a line segment from going from one point to another. And essentially what this does for us is gives us the vector function, which is equal to 1 minus t times our initial position and plus t times the new position. And that'll give us our equation of a line in three-dimensional space. Or we can say that x is equal to 1 minus t times x0 plus tx, y is equal to 1 minus t y0 plus ty, and z is equal to 1 minus t z0 plus tz. So, in single variable calculus, we integrated the function f of x as the function of a single variable over the interval ab. So, when regarding the x concept, or component, we took all the values within the interval from a to b. So in multivariable calculus with line integrals, we are going to regard the x and y components that are the value that make up the curve C. So knowing that our curve C is comprised of two components, it would give us the following equation. X is equal to h of t and y is equal to g of t over a is less than or equal to t is less than or equal to b. So as you can see, we're going to be deriving in terms of t. So therefore our line integral is actually, simply put, the integral of c with our f of xy ds. But now ds isn't in the same units or components as our function. So in order to make some adjustments, what we have to do is we have to parameterize our function and we have to substitute in for ds. So instead of making this f of xy and ds, we have a large substitution that makes it the integral of our line integral is f of xy ds is equal to, from b to a, of our parametric f of ht integral gt, and that is going to be multiplied by the square root of dx dt squared plus dy dt squared dt. And now we have a parametric equation. And this is also the same thing as stating that the line integral from f of h of t, g of t, multiplied by the magnitude of r of t, or our vector function. And this is the same thing because this is just the square root, or our magnitude we know is the square root of a component squared plus another component squared, and we're dealing with x and y here. So that is the line integral. I hope that helps. If you need additional information, there's a bunch on the website. Thank you.